The mean value theorem is what we're going to be talking about right now. If you remember, lines that are parallel have the same slope. So what the mean value theorem is kind of about is this. Let's say I have a picture and its x-coordinate would be A, and at its other end, its x-coordinate would be B. So obviously the y-coordinate for A would be f of A, and at B would be f of B. So if we connect point A to point B, we formed a line, also called a secant line, and to find the slope of that secant line, we would simply do change in y over change in x. So that would be f of B minus f of A over B minus A. Okay, so y2 minus y1 over x2 minus x1. So that's the slope of the secant line. What the mean value theorem states is there is at least one value at C. So let's say C would be right here. And actually, let's make this look a little bit easier for you. So C would be right here. Okay, and if we follow that down, there's C. And its y value would be f of C. And we can draw a tangent line to the graph. Sorry, really bad picture, but you get the general idea there. A tangent line to the graph at point C such that that blue line, which is the tangent line, is parallel to the secant line, which is the red line. Now, if you recall, a tangent line is equivalent to slope. So really what the mean value theorem then states is the derivative at point C, right, because a tangent line is the same thing as slope, which is the same thing as derivative, is equal to f of B minus f of A over B minus A. Okay, and that's putting it in simple, in simple terms. We'll talk a little bit more about it tomorrow in class. But again, just remember that two lines have the same slope. So the blue line, which is your tangent line, which is represented right down here by your derivative, that slope is the same as your secant line slope, which is represented over here just by doing basic change in y over change in x. Okay, so we will tomorrow discuss mean value theorem a lot more in detail and apply it to some problems.